Hello all, let's start with chapter number 10, Light. So I would be covering previous year questions today. So let's start with the first question. So it says if the image formed by a convex lens is of the same size as that of the object, what is the position, nature of the image with respect to the lens? So for answering these type of questions, you should know the ray diagrams by heart. So if you know, then you can immediately say that it will be real, inverted and will be formed at the center of curvature of the lens. You can also make this image, you can also make the ray diagram in this type of question. Now moving on to next, it says for the same angle of incidence in media P, Q and R, the angles of refraction are 45 degree, 35 degree and 15 degree respectively. In which medium will the velocity of light be minimum? Give reason. So as you know, we have Snell law in this case. So it says sin I over sin R. Sin I in this case is angle of incidence and R in this case is angle of refraction. So we know that N is equal to C over V and it is also equal to sin I over sin R. Now using these two equations we have C over V equals sin I over sin R. So using cross multiplication, we get V equals C over C times sin R over sin I. So in this case, as you can see, we need to tell them in which medium will the velocity of light be minimum. So it will be minimum for minimum value of angle R. Why? Because as you know, lesser the angle, lesser be the value of sine. So if we have less value of sin r at numerator, then V will be minimum. So that's your answer for question number second. Now moving on to next. It says differentiate between reflection and refraction of light. So reflection, as you know, is bouncing back of ray of light in the same medium after striking with the surface. Now refraction is bending a ray of light when it travels from one medium to another medium. In case of reflection, we have I equals angle R, whereas in case of refraction, we have I is actually not equal to angle of refraction. Then in the case of reflection, we have reflection can take place from any surface, but refraction can take place from a transparent interface like air, glass, air, or so on. Let's move on to next question. It says name the spherical mirror used as shaving mirror. So in shaving mirror, we use concave mirror as we want to see the image as magnified. The second one, rear view mirror in vehicles. It is convex mirror as we want to see the wider path behind our vehicle. In the third one, reflector in search fights. So it is concave mirror you can write, or you can write concave parabolic. So you can simply write concave mirror in this. B part of same question, it says write any three differences between a real and virtual image. This is very important. So you should know what is real and virtual image. Real image can be taken on a screen, whereas virtual image cannot be taken on a screen. So you can get image, that is, if you get image on screen, then it is real. Otherwise, it is virtual. If you can't get the image on screen, it is virtual. Now, real image is always inverted. Inverted means if you have an image like this, the inverted image will look like this. And in virtual image, it is always erected. That means same as the object. Real image, in the real image, third difference is that you can write that reflected or refracted rays actually meet at a point, then real image is formed. Whereas in this case, in virtual image, it says when reflected or refracted rays appear to meet at a point, then a virtual image is formed. Moving on to next. This is again very important question from the viewpoint of this year board. So as the velocity of light increases, the refractive index of the medium decreases. Light enters from air to water having refractive index of 4 over 3. Find the speed of light in water. Speed of light in vacuum is 3 into 10 raised to power 8 meter per second. So in this question, C is given, that is speed of light in vacuum. And we have one it says light enters from air to water having refractive index of 4 over 3. So as you can see in equation 1 it says n equals 4 over 3. Now we need to find the speed of VAW. I can write it here. We need to find this. We need to find speed. So speed is nothing but equal to C over N AW. So we need to find the value for this. So C is 3 into 10 raised to power 8 and N is 4 over 3. So when you solve this, you will get your answer as 2.25 into 10 raised to power 8 meter per second. So that's your answer. Moving on to next, it says an object of height 5 cm is placed perpendicular to the principal axis of a concave lens of focal length 10 cm. So in this case, height is given, that is plus 5 cm. Then it says the focal length is 10 cm, that means negative 10 cm in the case of concave lens. Now moving on, it says if the distance of the object from the optical center of the lens is 20 centimeter, that means U is given, that is minus 20. Determine the position, nature and size of the image formed using the lens formula. So as you know that the lens formula is 1 over f equals 1 over v minus 1 over u. Now interchanging the value of f and v, so that we can easily put down the values of f and u, and then taking LCM of 10 and 20, that will be 20. So we get the answer as minus 3 over 20. So 1 over v equals minus 3 over 20 and v can be written as minus 20 over 3 using cross multiplication. So it is minus 6.66 centimeter. Now the image will be virtual and erect as according to V we observed, and then we need to find the magnification as we need to find the size of the image as well. So we would be using the formula of M, that is H dash over H equals V over U. So putting the value of it, so we get, putting the value of h, v and u in this, and we get answer as 5 over 3 centimeter, that is 1.66 centimeter. So that will be the height of the image. Moving on to next. One half of the concave lens is covered with a black paper. As you can see on your screen, we have a convex lens and one half is covered with black paper. Show the formation of the image of an object placed at 2fp 2f2 so that such covered lens with the help of ray diagram mention the position and nature of the image. So there will, if the lower half of the lens is covered, even then it will form a complete real and inverted image, as there is no role in having in changing the size of the image. So in this you can see that we get the image at 2f2, but it would reduce the intensity of the image. That's the only reason. That's the only problem we can have if we have black paper on one half of the convex lens. Now it says draw the ray diagram for same object as at same position in front of the same lens, but now uncovered. Will there be any difference in the image obtained? In the two cases, give reasons for your answer. So as you know, as I said earlier, there won't be any change in the nature and position of the image because there can't be, there basically the black paper cannot change the image. So here you can write there will be some intensity change in this case only. Thus, there is no change in this. So, moving on to next. Next is what is meant by power of a lens. So, power of a lens is the ability of a lens to converge or diverge light rays passing through it. And as you know, it is actually a reciprocal length. So, 1 over f. And we need to tell them SI unit as well, that is diopter. So moving on to the question part, it says a student uses a lens of focal length 40 centimeter minus 20 centimeter. So the first one, if the focal length is positive, that means it is a convex lens. And we get the power and see on your screen, it is plus 2.5 diopter. For the second one, as the focal length is minus 20 centimeter, that means it is a concave lens. So in this case, the power will be minus 5 diopter. So that's all for this part. Moving on to next. In this question it says define radius of curvature focal length of a spherical mirror. Show it on a figure. Write relation between radius of curvature and focal length of a spherical mirror. So for this I will suggest you to write down all the definition of this chapter because they are all are very important from the viewpoint of CBSE board. So write down all the or learn them by heart so that you can write down in your examination of a curvature. And the focal length is the distance between pole and half of radius of curvature is also known as focal length. So as you can see, it is still focal point and it is from pole, and radius is actually the twice of 2f. So focal length in this case is actually half of the radius of curvature, and in the second case again it says write the relation between radius of curvature and focal length of a spherical mirror. So it will be f equals r over 2. Start with next. It says define real image of an object. So real image is formed when the reflected rays after reflection actually meet at a point, then only a real image can be formed. Now moving on to B part, it says name the mirror that can give real as well as virtual image of an object. So it could be only from concave mirror. The second one will always give virtual image of same size of an object. So it is a plane mirror. Third part will always give virtual and diminished image of an object, that is convex mirror. Then fourth part says is used by a doctor in examining teeth, that is concave mirror again. With the help of ray diagram explain the use of concave mirror as solar concentrator. So in this you can see that it, that all the rays are focused with the help of a mirror, and in this case you can see it is all concentrated at focus after reflection. So that's what the solar cookers are based on and solar panels are based on, so that they actually help us in having a solar concentrators. With the help of a concave mirror we can make use of this. So that's all. You can draw this figure in the B part of it. Now moving on to next, it says name the type of mirror used in the following. Solar furnace. So we use concave mirror in any case of the solar panel or solar furnace or solar concentrators. We always make use of a concave mirror because they are converging mirrors. B part, side rear view mirror of a vehicle. So in that we make convex mirror. Draw a label diagram to show the formation of image in each of the two cases. So like this you can make two ray diagrams using concave mirror and convex mirror, how they work basically. Which of these mirror could also form a magnified and virtual image of an object? Illustrate with the help of a ray diagram. So as you know, concave mirror only form a magnified virtual image of an object, and you can draw this ray diagram to verify your answer, that how they magnify the image. So how they magnify object. Moving on to next, it says which lens can be used as a magnifying glass. So it is one only, that is convex lens, because it has a shorter focal length, therefore can be used as a magnifying lens. Now, for which position of object does a convex lens form a virtual and erect image? In B part, a real and inverted image of same size as that of a object. So in this case, you have to draw the ray diagram for both. In the first one, as you can see on the screen, a virtual and erect image has been formed. Virtual A dash B dash is the virtual image, and it is erect, same as AB and magnified too. In B part, a real and inverted image should be there, and they should have a same size as of object. So you can see at 2F2 you get a same image as object. They have same size. So you have to draw the ray diagram for each case in the light chapter. Moving on to next, it says draw a label diagram to locate the image of an object formed by a convex lens of focal length 20 cm when the object is placed 30 cm away from the lens. So in this case, focal length is given, that is 20 cm. U is given, object placed, that is 30 cm minus 30, and as you know the lens formula, 1 over V minus 1 over U equals 1 over F. So putting all the values in it, you get your answer as 60 centimeter. That means the image distance is 60 centimeter. Now F is 20, R is 40, and U is 30. So you have to depict that on a ray diagram. So you have to mark all the points with the help of the given things you have. That is V, U, F, and R. So you have to mark all the points you have. This is U, F, V is 60. This must be 60, and that's all you have to mark these points basically. Now moving on to next, it says define absolute refractive index. The path of light ray from three different media A, B and C for a given angle of incidence is shown below. Study the diagrams and answer the following question. So for absolute refractive index, you have to write write that it is the ratio of speed of light in air vacuum to the speed of light in medium. So you have to define the ratio part of it. Then in the second part, it says through which of the three media will the speed of light be A, B or C? Air, then medium A, air and medium B, and air and medium C. So in the we have to, which of the three media has maximum optical density, that means N. So it will be medium C, as N is equal to sine I over sine R, and in this case the angle of refraction is 40°. So the sine I, or the maximum optical density, will be in this case maximum. Now moving on to next, it says through which the three media will the speed of light be maximum. So it will be in this case A. Why? Because the angle of refraction in this case is 50°. So therefore the speed of light in this case will be highest. Now moving on to third part, it says will the light traveling from A to B bend towards or away from the normal? So it is towards normal. Why? Because it is lesser than 60°. if it would have been greater than 60 degree, it would be away from the normal. But if it is lesser than 60, this angle, then it would be towards normal. Now last part of it, it says will the refractive index of B relative to C be more than unity or less than unity? In the case of will the refractive index of B relative to C be more than unity or less than unity? It would be less than unity as they have both angles lesser than 60 degree, so therefore it will be lesser than unity. Now moving on to next question, it says write relation between U, V and F for a lens. So in this case you need to write the lens formula. In the second part of it, it says you have to write for mirrors. So 1V plus 1U plus equals 1F. So this is mirror formula and this is lens formula. In the second part it says the magnification of concave mirror is plus 4. Write the information about the image given by this statement. So if m equals to plus 4 of a concave mirror, that means it would be virtual and enlarged image is formed behind the mirror. Now C part, it says draw a ray diagram for the following and show the formation of the images in case of concave mirror when the object is placed between the pole and focus point at the center of the curvature. So you again need to make the ray diagrams for both. Ray diagrams are one of the important from light chapter. Again moving on to next numerical, it says 5 centimeter tall object, that means h is given to us perpendicular to the principal axis of a convex lens of focal length 20 centimeter, that means f is plus 20 and distance of the object, that is u equals minus 30 centimeter. You need to find the position, nature and size. We can find position with the help of length formula, that is 1 over v minus 1 over u equals 1 over f. Putting all the values, you get v as 60 centimeter. That means the distance from point O till the image, it is 60 centimeter. Now nature. Nature of image will be real, inverted and magnified. Why? Because you can see the distance is 60 centimeter. It would be a real image and it is a convex lens. So inverted and magnified. Now in the third part it says size of the image. So we can make use of magnification formula and put all the values here and you will get your size of the image. Now moving on to next, this is the last question for this chapter number 10 in case of 3 markers question. So two lenses have power of plus 2D and minus 4D. This is same we did. So if you have power, that is plus again, this will be a convex lens and you get your focal length in centimeter. So when you solve 1 over 2, it will be 50 centimeter. Now in the case of second part, it is minus 4D. So when you solve this, you will get minus 25 centimeter. Again, as it is minus, that means it is a concave lens. If it is positive, it is convex. If it is negative, it is concave. Now an object is kept at a distance of 100 centimeter from a lens of power minus 4D. So power is given. From power, we can get F is minus 25 centimeter as solved in upper part, second part. So we know F, we know U, object distance is 100. So if we know the value of U and F, then you can get the value for V using lens formula again. So in this case, they get answer as minus 20 centimeter. So this is the end for chapter number 10. I will continue with more videos. Have a great day ahead.